Hi there, everyone. I'm really excited to be here with you today. We're going to be talking about how unit testing can actually be easy. My name is Eli Lopian. I'm the founder of Typemock. I've been through many different positions in software development, from an intern, software developer, team leader, CTO, and CEO. I'm going to share a bit about my knowledge about unit testing. I had this slide here, but I want to start by telling you a story. This happened about 10 years ago. I was working for a large company with thousands of developers. And one day my best developer came into my office. I remember that day. I was going through my emails and she came storming in. She was very frustrated and angry and said she couldn't take it anymore. She wanted to leave. She wanted to quit. And I understood that I was also really frustrated because our division was working at coding for about 3 months, and then it took about 9 months for the QA to release the product. And during these 9 months, we were working on the next version, but everybody was frightened because every few days the QA used to send us a bug, and we had to stop working on a new version and go back and fix the old version and implement that fix in a new version as well. So that's a lot of context switching and going back and forth, and it really got the team frustrated. And everybody was blaming everybody around. The QA were blaming the developers for not writing good code and for putting in silly bugs, and the developers were blaming the QA for not understanding the software and not configuring it correctly, and for putting in very low level bugs like the wrong color green or something like that. And so we were having a really bad time here with this. And I really tried to fix it. And that weekend, I met a friend of mine over a beer, and he told me that they're working on some new kind of development way called XP, Extreme Programming. I don't know if you guys know about this, but this is one of the first agile methodologies out there. I was really intrigued by it, and I started to read about it and to see it in action. I went to their company and saw it in action, and I was amazed. I loved it. They were releasing every 2 weeks, and they were doing pair programming, and they were doing test-driven development, and it worked. So I started implementing it with my software development, my best programmer. We implemented it in this small team, and it didn't take a long time. It only took a few months, and we were having 0 bugs in our team, and we were delivering on time. So that was amazing, and everybody was looking at us. And we said, let's implement it at the rest of the company. Now, we're talking about a very, very big company, and it's a very complex and difficult mission, both technically, how do you TDD with legacy code, and personally, developers want to write code, not write tests, and this is the QA's job to do the testing and stuff like that. And we learned a lot about the implementation of unit testing and figured out what the tooling should be. And one of the things that I noticed was that there wasn't enough tooling. And that's when I went out and I created Typemock. The idea behind it is that if one piece of code calls another piece of code, and we don't want it to call it because it's complex, we can isolate that and we can mock that and do something else. So for example, and I'm going to draw on this so you'll be able to see. For example, if I have a test over here, this is my test, and it calls some kind of a database code, which calls an actual database, okay? This could be problematic, this database here, because it might not have the right information in it. It might be down. It might have different stuff inside. It's really hard to make sure that the unit test is still a unit test and it's still fast and it only checks a specific thing when you have a connection to the database. So having all of this as part of the test makes the test more of an integration test than a unit test. Okay, so different examples are databases, web services, random numbers, date time now, all these different things that can be non-deterministic or very hard to set up. We don't really want to call it because it's not really part of what our code does. So what we do an isolation. Okay, so the isolation basically tells this component that instead of calling the real code, it should call a fake code. Okay, so instead of calling the real code, it gets, I could call it maybe hijacked and it doesn't call our normal code, it calls fake code. So this fake code is fast, it's quick, you can set it up, it's deterministic, and then we can tell what kind of environment we are, and it's very easy to test it. Okay, so within the test itself, we define what happens in these little pieces, and then it's easy to test the test. We should be mocking and faking objects that are very slow, database, network, all these very, very slow pieces of code. Complicated to set up. Database is also something that's very complicated to set up. There are many different ideas of what can be complicated to set up, but if the setup itself is very complex, then it's easy to just fake out those methods and fake out those methods. Stuff that are not deterministic, like datetime now, and like random kind of code that every time returns something different, and we don't know how to set up the test that will be the same scenario every time. And stuff that are not really interesting to test. For example, if you have a logging system and you don't need this logging system up, you can fake the whole logging system and say, you know, this is not important for me right now. And now I want to show you the other methodology where the actual developer, he's the one that writes the tests. And of course, you can write it after the fact, but I'd like to talk to you about what's called TDD, test-driven development, which is written before the fact. And the easy way to remember it is red, green, refactor. The first thing you have to do is write a test that fails. That's the first thing you need to do. The second thing, you have to make the test work, and then you can refactor it and eliminate redundancy. And of course, it's easy to refactor because all you need to do is make sure that all the tests pass. And let's have a little recap before we have some questions here. And we talked a bit about the importance of unit testing, how unit testing helps us become better developers, how it helps us speed up the development, how it makes everything automatic and fast, and it keeps us focusing on how to actually add new code and new features to our legacy code without having to manually test it and to waste our time testing it. We saw a bit about how artificial intelligence tools can help create unit tests for you with the code that already exists, and you can see that, and you can change the suggestions, and you can build on that to create more and more tests. We saw a bit about how mocking can help you create unit tests, keep them in the unit test, keep them fast, keep them simple, keep them testing a small part of the code so you can test a really broad amount of scenarios. We also have a little glimpse on how to implement TDD to your work routine, write the test first, then only afterwards write the code. So this is basically our introduction to unit testing. It should be enough here to get you started testing the simpler methods of your code, and as you continue and as you grow, you'll be able to test the more complex parts as well. Okay, great. So thank you very much, everybody, for being with us. And I hope you learned a lot. I'd love to get some feedback from you, and I'll see you next time. And if those of you who haven't done unit testing or want to see what it is using Typemock tools, you're welcome to go to our website and to download it.